Welcome to the Cannabis Equipment News Podcast.
Hi, I'm David Manti, and welcome to a new episode of the Cannabis Equipment News Podcast. With me today is Terry Van Gelder, president at AGT Technologies. Thank you very much for joining me today, Terry.
You're welcome. Please be.
All right, before we get started, please make sure to like, share, and subscribe to the podcast. You could also help us out a lot by leaving the podcast a positive review. Finally, if you want to reach the podcast, you can reach me at david@cannabisequipmentnews.com with email the podcast in the subject line. Finally, recently came to my attention that some people think this is just a podcast and not a website. You can reach more information at cannabisequipmentnews.com. It's real. I swear. All right. So I was looking at your profile, and you have more than 40 years of experience at AGT. How have you been doing this for 40 years?
Well, it's a combination of my background, which is all in agriculture, and with the agriculture background, both in dairy and row crop farming, which we have a family farm still in Southwest Iowa, which grain farms. But I got into the grain handling systems, drying systems, building systems, and then moved out here to California and spent 40 years in the construction industry. Basically build everything from, commercial, industrial, medical, you name it. And my last 8 years was with the Department of Defense, building aircraft hangars. And then along came the greenhouse market, and here we are now.
So how did the greenhouse market come along? How did you find yourself in the cannabis market all of a sudden?
Well, I was approached by a group out here in Coachella, California, and they said, hey, can you develop and design a greenhouse with your traditional commercial building system? And I said, well, yeah, sure. I'm, quite capable of doing that. So I went to task with it and started getting in it very heavily, and realized that this is a great market to be in, and discontinued my business within the Department of Defense, which was aircraft hangars, and and dealing with their energy codes, and transferred all that technology, especially with the Department of Defense, over to this design. So I was asked to participate, so now we have a system that answers all their problems within the interior of the building.
So what was the original commercial building system that it was based off of? Is it sort of a modular, I don't want to say cookie cutter, but can you tell me a little bit about the building system?
Right. Well, it's the same system that we use to build aircraft hangars. And it's the same building system that you go into Home Depot, Lowe's, Costco, any of those. That's a commercial building system. And so, we don't use greenhouse framing. That allows us to go any height, any width, any length, and build anywhere. These are Dade County rated, meaning that's a hurricane rating. And so you can put one of the buildings we designed was 207 mile an hour wind load. You can't do that with a traditional greenhouse. It'd be scattered from here to next year if it got hit with that kind of wind load. So, back to you. I mean, that's pretty much, the commercial building system is just that. So, we can go into the details of how this building is constructed and how it answers every problem that, exists in the indoor market.
Before we get into those details, what was it that you finally made the decision to get out of the hangar business with the Department of Defense and go full into cannabis?
Well, it's the market was there. And, when I designed this, of course, I put it under patent pending protection as well, because no one's ever done what we've done with this system. And I'm going, look, this is something that, will take off, because everything that they have a problem with has been addressed and resolved, from condensation to energy. So I figured it'd just take right off. But here you always get a pushback because it's a new product. So that's what we deal with, is the pushback on a new product. And we can get into that, how we address that, down the road.
Okay. When you talk about getting into some of those details, what is it that you're doing that no one's ever done before?
Well, the greenhouse system, when I initially designed it, I submitted it to the Thomas Edison Foundation under energy and sustainability. And it wound up coming home with a gold medal, and Dow Chemical Company was second, and Johnson Mechanical Controls was third. And those are both international companies. So in it of itself, you have the professional credentials already, but to explain what the difference is between this and every other greenhouse on the planet is that, as previously mentioned, we start with a commercial frame. So the roof on this system is almost flat. So we put a ceiling system in here. So what we wind up with is the exact same windows that you have in your office building. It's a dual membrane system. So you have an outer wall and roof, and then you go to the inside, use the same framing. You line the entire inside with an interior wall panel, and then you put a ceiling system in it. What that does is completely encapsulate the entire steel structure. So that means now you have just like a dual pane window. So it's insulated. So we have our values that are 6 times what any greenhouse company has because of the dual membrane system. And that gives it, we brought this to the California Energy Commission as well, and Energy Solutions, who wrote the new California regulations. And this system far exceeds all of their regulations that are required for energy. So you have the insulation value of the outside panel and the insulation value of the inside panel, and then you get the dead air space. So that creates a dynamic that the cold cannot penetrate that, because what we do inside there is that we run that air cavity, and it runs to be about 30 inches deep on the wall, and the roof is the same, and it can exceed, it can get up to 4 foot deep. So in that air chamber, what we do is we run 100-degree air, dry air all the time. What that does is now takes and gives our internal panel and outside panel 100-degree temperature at all times. That means no condensation will form on these panels, not on the ceiling or on the wall panel. So, that's what sets it apart from everybody else. So the dual membrane system in that of itself, and we haven't even got into the CRAM generator, how we get this to net zero, but that gives you gives you a 50 to 80% energy savings based on the insulation value alone, because you're 5 times the insulation value that any other greenhouse is. Plus, you now have completely even temperatures because you have a ceiling in it. A traditional greenhouse is a jagged roof system. So you're going to have a jagged air temperature because it follows the roof line. See, like any commercial building, you got a ceiling in it, and how that's designed on HVAC systems is simply length, width, and by ceiling height. That gives you an exact amount of cubic feet of air that you're conditioning, and the ceiling holds the temperature level. So that's the major difference. And that also, this system is a clean room operation because of that. So you have the interior wall and interior ceiling, and you regulate that temperature so you don't get any condensation, but it's a clean room. So you have an airlock actually to access the greenhouse. That's so you don't bring any airborne viruses or any pests into it. It's an air exchange, not super complicated. It's just like any other scientific lab that you go through. You go through an air exchange, and then you access the greenhouse. So, in a couple other, since we're on the interior air, we use another an air sterilizer on the interior air. So what we do, it's a military air sterilizer. So it kills all plant and human airborne pathogens, virus, et cetera, et cetera. So what you're doing now is you're growing in a pure environment. So the air is completely pure. Plus, with that system, we have what we call climate match. Climate match means it will go to any location in the world, set up sensors. It'll pick up whatever atmospheric pressures, gases, and sunlight on a year cycle. We will come and plug that into the system. It will replicate that exactly inside this greenhouse because, see, it's sealed. The roofer, it does not open up. And one of the big things about the air sterilizers, are one of the big issues with cannabis, is the odor. So this is a sealed system, but the air sterilizers themselves neutralize 90% of the cannabis odor. So you don't have any, essentially 10% of odor inside the greenhouse that you would actually, be inhaling. So, it covers that. In this system, also complies with the FDA pharmaceutical manufacturing regulations. That no greenhouse on the planet does, except this greenhouse. And the reason it does is because it has a clean room interior. So what we do is it's the same regulations that Bayer, Pfizer, Merck, Johnson & Johnson, and all the rest of those guys have to comply with. When they manufacture a pharmaceutical product, it's got to be done in a clean room. In fact, they don't even allow you to have the lights hanging down from the ceiling because they consider those a magnet for dust. And if you get condensation, that would drip down into your crop. And that's the problem with traditional greenhouses. Mm-hmm. Look, when the temperature drops to 40, 50, 40, it's physics. They will condensate, period. There is no way to stop it. And that, you have a dirty frame up there, they may look clean, but they're not. That's where it's just like moss. That's where your mold and, your fungi and bacteria starts up there because it's hot and humid and you don't see it and it drips off the frame during condensation and it gets into your crop. And how many articles do we have to see about mold before they get, it's true.
Yeah.
It's everywhere. Is that problem? So we eliminate that.
Mm-hmm. So that is, all of that makes sense to me. And then you tell me that you're still getting a lot of pushback from the industry. Where's the pushback coming from?
It's new technology. See, they ask, well, where's your facility so we can go look at it? And I go, look, we haven't built our first one. We had one on the books, and that was in Missouri, and then they did not get their license. That was another fiasco. But we have a couple other ones, on the books again. But, they just go, how do we know it's going to work? And I'm going, you have to, look, this is how I answer that. I go, if we were to walk in your old school greenhouse and we would have put a full interior ceiling and a full interior wall system, would it work? Do dual pane windows work? Do they insulate? Yes, it's exactly the same thing. Is the sun not going to shine through that second layer? Of course not. Does the sun still shine through your window? Yes, it does. So you try to put it in most simplistic terms, but the bottom line is they want a wheel to kick at the end of the day.
Yeah.
So David, the thing that I'm telling you here is that everything that we have done in this system, including the underground system, which we can touch on a little bit here in a minute if you want, everything we're doing in this system has been done in the commercial and industrial market. The dual membrane system, we've done that in the commercial market. It's been done in data centers. And everything we're doing, the only difference between that and what we do is the ceiling, the panels are clear instead of opaque. That's the only difference. And all of this is stamped off by registered engineers. They're not going to put their name on something that doesn't work. So, there we are. So, back to you on the system.
What, if you've been doing it 8 years, and you're still working on getting the full, like your first build. How have you persisted in the industry, amidst that pushback?
Well, it was introduced in 2019.
Oh, okay. Okay. So the system is from 2019. Okay. Gotcha.
We introduced it then, and we just started putting it out there. We didn't, do anything. And then we had a customer come in that was going to be into the new Missouri market. And, that was brought in by a contractor, and, they signed a contract with us to build this, and then they didn't get their license. So, I'm persistent. The system works. I stake my life on it. There's nothing that won't work. Everything is there. And, it's the same thing, people go, well, gee, how does this work in the wintertime? You guys got a flat roof. Well, it's real simple. All we do is kick the heat up to 150 degrees and the snow melts on contact. It's done by a sensor system. So you never have snow on it. That's why we use a quarter on 12 roof slope, because you don't have any snow buildup. Even if you had snow buildup, it would still support the weight. But that's not the point. The point is you still want the sunlight, so it just simply melts on contact.
And I guess because it's a different animal, I feel like you could just say it's been successful. Like there's been success in the military industry, medical industry, pharmaceutical industry. It's going to work in cannabis.
Well, I tell them the same thing, David. It's even, they go, okay, well, the bottom line is that's the pushback you always get. How do we know it's going to work because you haven't built one? Then I say, look, okay, if the first example doesn't work with us going in your greenhouse, let's walk over into the other facility, which is an indoor grow. Okay, what is an indoor grow? An indoor grow, now you're growing with lights. So I said you have an inner wall and an inner ceiling, right? Does that work? Well, yeah, it works. Well, we're doing nothing different. I said we have a inner wall system and a ceiling system, exactly what an indoor grow is, except that the ceiling panels are clear and not opaque like they are. And even in their system, when we do an indoor grow, we do it exactly the same way, David, because here's what happens in those grows. If you take for example, if you just take a metal building, and you go in there, you build it, and then you go in there and you build out these walls with steel studs and roof with steel studs. Okay, now you still get leakage up into that air cavity, and that's moist air, and it will still condensate on the structure and drop down on your ceiling system. With our indoor system, again, the way we do it is we utilize the exterior frame system. So we put that exterior wall in. It's not the exterior, it's the interior wall, but at the exterior perimeter. And then we go in and put the ceiling in. We do the exact same thing because we run dry air now in that air cavity again at the wall and roof and ceiling. And again, regulate the temperature so you don't have condensation on an indoor grow. So it eliminates your condensation. Now you got to heavily, and even in that building, what we do is we put skylights in there, insulated skylights with blackout systems on the skylights, so you can supplement your light even in an indoor grow. So,
okay. No, that was the supplementation I was interested in because, I hear a lot about people that love free photons in this industry, right? So I was wondering, are you sacrificing anything with the double layered clear roof system? And does it need to be supplemented with LEDs or other lighting systems inside?
No, it all depends on your location again. It isn't any different. You still have the same exact light transmission. See? And that's the difference because look, it's the same as your window. You're simply putting another pane on there. The transmission value of the light is still the same. So you don't sacrifice anything, but you gain the insulation value of the wall and roof system. And, another thing that we do in there, in our trip down to the FDA, because we've had this at the FDA as well, once this hits federal legalization, of course, this conversation was off record because it's not legalized at the federal level, but they were addressing it based on current drug manufacturing regulations. So that the question was brought up, okay, can those screens you guys are using in there, those are another bacteria, fungi magnet. They are not going to allow those screens in the room itself. So we designed our system where the Blackout system is above the ceiling so that it operates up there and it is not in the room as a contagion magnet that will be, disqualified for you to get the FDA approval. So we put that system above the ceiling system. And here's another thing, which brings up the screens. So you always have light pollution. Now you could take care of that with the Blackout system, but we've also have what's called a natural cloud cover. What the natural cloud cover is, again, you got to remember now, hey, we got this air chamber in there. It's 30 inches deep at the wall and 40, 50 inches at the ceiling. So what we do in there, we got that dry air in there so you don't have condensation, but we also have a dry pharmaceutical grade hazing unit. So what we do is, if you will, a Halloween fog machine, but it's anything but that. This lasts for up to 4 hours. So when the sun is too intense, perhaps let's say you're in the desert now and it's 120 degrees. Okay, and the sun is beating up on the plants and you're starting to get some damage because of that. Well, what we do, instead of using screens, we have light sensors in there that once it reaches that point, the sensors kick on the hazers and fog out the entire roof and walls. It takes all of about 2-3 minutes. That's how fast it works. And so now you just simply diffuse the sun. It's like going to the beach when it's a cloud cover day. So you simply turn these hazers on and get it to the density that you want, and then it turns off. And so now you won't damage your plant, with the high sun. Plus it also, adds another layer of insulation inside there when we use the hazing. So, it's another thing, the Blackout curtains, the way they do those now, it's just not going to fly once they get into, hey, you got to be in a clean room operation, just like Bayer, Pfizer, and the rest. They're not going to allow it. It simply has to be a clean room.
What are these Blackout curtains and screens that you're talking, like, those are used for cover when the sun's too intense?
No, the Blackout screens in the cannabis are used at the last growing cycle where they completely black out the room.
Okay.
So the room is completely blacked out, and that way the plant is manipulated into producing, the flower prematurely because I think it's fall. So that's why they use the Blackout curtain. So the rooms are, basically pitch black for a certain period of time to get that plant to completely flower out so that, it shortens up the growing cycle.
And you're able to accomplish that with that hazing?
The hazing is close. And we haven't done any studies on, hey, the people that are using Blackout curtains, it's completely blackout. But in the real world, when you're talking about nighttime, and that's what we're trying to duplicate here, you still have celestial lighting in the sky. So there is some lighting come through, and we haven't taken it to task yet. Once the first facility is built, we'll go ahead and it will be tested in a small area to see. But from what we see, we can get it black enough with the hazing because it's like smoke. You can't see your hand in front of it. So yeah, you're going to be able to get it to that level with it, but we just need to run it down the trial first before we say that 100%.
It's harder to imagine because nobody smokes indoors anymore.
I know, but again, you're not exposed to it.
Yeah.
The hazing,
no, yeah. I just mean in terms of like how opaque it can actually get.
Yeah, right. I mean, it's, but it's just like driving in fog. I mean, you just, when it gets so thick, and it can get thicker and thicker and thicker, you just can't see at all. The more it goes, the more intense it gets, the more dense it gets, the less you're going to be seeing through it. And again, it's like when the smoke shows up when we have fires out here in California, it blocks out the sun. So that's how we use that. And that way you don't have any screens to break. And like in the food industry, they have like 4 different levels of screens that they use. But again, you don't have to do that, because all you do is set the sensors to the diffusion level you want. The hazers kick on automatically, and it's done. It's just that simple. There's no mechanics to it whatsoever.
What is the underground system that you had mentioned earlier?
Well, the underground system is, they're, like I said, again, here, the underground system is not something per se new, because, they've been putting furnaces in the basement for a long time. Okay. So what we're doing is there's 3 chambers. So you have a heating chamber, you have an AC chamber. It's a basement, the full length of, they're basically a 10 by 10 chamber, 10 foot by 10 foot by the length of the greenhouse. So they run essentially under the center. And then we have what we call a natural earth air system. And that's the real energy saver in the system, because the other ones are operating off of, energy. But natural earth side of it, we run a series of pipes in the soil, because see, the soil runs at 55-degree temperature at all times. So we just simply run the piping below the frost line, and the piping's in a looping system, and then it has a coolant in it. So when the coolant comes back at 55 degrees and it goes to the top of the radiator, we have our 8 foot by 8 foot radiators, and that coolant goes through it. We have low speed aviation fans behind it. So that entire chamber is at 55 degrees. So the mixing, see, there's one big fan system. We put the air out at anywhere from 120 to 200 miles an hour. You would say, well, that's going to, tear up the plants. No, it doesn't. And I'll explain how that works. So we take that 55-degree temperature, it goes through a mixing fan. So if it needs hot air, it pulls from the heating chamber. If it needs conditioned air, humidity or coolness, if you overrun the natural cooling and natural earth cooling system, that's always running at 55 degrees in there. So that is really cooling your greenhouse all the time. But when I get to the airflow, the way we do this is it goes up into a tube directly from underground straight up into the greenhouse. So you don't have it being transferred for 200-300 feet through ductwork. It's straight up into the greenhouse. Now what happens is it goes all the way up to the ceiling. Now you got to remember, we have a ceiling system, and our lights, they're either right down on top of the growing system. We have our own growing system as well, but either they're right on top of the growing system, or they're recessed into the ceiling cavity, just like a canister lighting in your office, or say a T-bar grid system in your office. The light isn't hanging down; it's flush with the ceiling, and that's how our system is built. So now what we do is we run this air up at the ceiling level. Let's just say the ceiling level is 18 feet, and of course your plants are down there at 6 feet. So the air is blowing across right at the top of the ceiling. So the air comes out anywhere from 120, depending on the width of the room, to 230 miles an hour, and it shoots across the room to the opposite side to your intake. Now we move over a little further and we reverse that. So now the air is coming from the opposite side of the room and coming to this side. And what that does is it creates a vortex, so that you get your circular motion, because the air is flowing at different ways, and that's replicating what it is in the real world out in a field. The wind is constantly changing direction, and wind is great on plants because it strengthens it. So, down at the plant level, it's not 200 miles an hour. It's a nice gentle breeze down there, but it creates a twisting motion and a vortex, so that, is good for your plants. But again, the lights have to be recessed, because that is creating an atmospheric flow, just like we have atmospheric flows in the atmosphere. The wind is, creating, vortexes up in our atmosphere. Well, we're just recreating that down here in the greenhouse. So, that really kind of covers your underground system, because the rest of it, it's a matter of locating the mechanical system underground. So here's another thing we do with that. Okay, so I'm getting into why we use electric heat. Everything is electric. Okay, but when we get to the HVAC system, they're putting off heat all the time. The fans are running, they're blowing heat. So we take that heat and we capture that heat, because a lot of these greenhouses are in, hardy conditions.
Yeah.
Minneapolis, any Michigan. I mean, you're in the snow area. So I was raised in Wisconsin, so I know 50 below. So it's a matter of, that's where we dairy it, but it's a matter of, hey, take that heat. Why are you setting the units outside and just blowing it into the atmosphere? You put it down in a confined area, and you simply recapture that. All that happens is it's transferred over to the heating chamber. So when you do need heat, you just draw from the heating chamber, and that goes back to the mixing fan again, which mixes natural cooling air, HVAC, dehumidified air, and heat. So however you do it, it's all drawn from those chambers. That way you don't have any AC units on the roof. When a greenhouse, you can't do that anyways, but you don't have any units sitting outside. And one thing I'll point out on HVAC systems, and then I'll turn it back over to you again, is that we don't use like big 200-ton units sitting outside the building. No more would we put them underground, even if we could. Each growing room has its own HVAC system dedicated, because you're recirculating that air in that room. And if you're growing different strains of cannabis, you're going to cross-pollinate. If you run it through a master HVAC system, you're eventually going to cross-pollinate. No filtering system's 100%. And in our filtering system, because it's a damp, you got, high humidity, we use an oil bath fan and an oil-laden filter system, so that the filter system will not degrade itself to where it won't work anymore. So it's kind of like these high-performance filter systems on cars. They're an oil bath or an oil-laden filter system that keeps your bugs out. And what the oil does is, you can put in these filtering systems, you can put like a if you want to call it a pesticide or a bacteria killing agent in this filtering system. You can, in the center of it. That way, all the air going through passes through. It will kill all bacteria going through this filtering system by itself. So, the one last thing, and, I'll open it back up for some questions, is going to be the CRAM generator. But if you have some other questions on this so far, you can let me know.
The question I had next was, where in Wisconsin?
Where's Wisconsin?
No, where in Wisconsin were you raised?
Well, we lived close to River Falls, which is a college town, which is where we always hung out.
Okay.
But we were raised in Baldwin, Wisconsin, which is, outside of St. Paul, about 30 miles.
No, that's, I'm based out of Madison. That's why I ask.
Oh, okay.
Yeah.
Way down south.
How long would it take to build one of these structures?
Well, they're just like any other structure. Now with the, any commercial structure. So you basically, you wind up with the same procedure that we go through on any commercial project. So you go through normally about a 3-month design period. Mm-hmm. Then it goes to the city, whatever municipality, you got a couple months burnt there. And so then you got about 5 months into design and permitting, and then you start construction. So depending on the size of the unit, but you're usually looking at anywhere from an 8 to 10 month build cycle. Again, depending on the size and how complex, the growing systems are, because you got to factor those people coming in once the shell is complete, then they got to move in. So their timelines, affect the overall construction, but just the shell itself, I mean, you can get under fast track stuff like we had to do for the military, and you can bring it down to 6 months if you want to, but it costs you more money to do that at the end of the day.
You mentioned some of the projects that you currently have moving right now. Are you going to be at all affected by the materials shortages that are kind of hitting a lot of companies?
Yes and no. What we wound up doing is, as the company that we worked with on NDAs is Blue Scope Steel, and they are an international company, and they own Barco-Pruden buildings and Butler buildings. And we were using their system mostly because the joist system that they had, it's a galvanized joist system. It's bolted, it's not welded. It's a very nice, clean, straight deal. And, they called me up, they invited me out to dinner here, here in San Diego County. We went out and, laid this bomb on me that, well, we can't deliver any buildings for a year. Well, I go, well, that's not really going to work here, because if we're trying to get this thing out there, we're having enough problems with it, right? Without telling them it's going to be a year now. So what we wound up doing, when I submitted this thing to, the patent office, I did spend money and do a design on not only the framing system, but also on the joist system, which is a similar joist system to what Blue Scope Steel has, but it's our own design. And so what happened with that is it wound up getting put into play a lot sooner than I ever expected to. So we wound up finding a fabricator in Phoenix who can roll form our joist system, and they're only out about 12 to 14 weeks, which is well within line, and they have plenty of material. And then with the framing system, instead of using their specialized Blue Scope Steel specialized system, we strictly went to a off-the-shelf structural steel system, just like you would find in Home Depot and Costco and all the rest of them. So now we're using standard shapes that are used in every facet of construction. That's a beam size that you pull off the shelf. They're not, I wouldn't call them plentiful, but at least now we have the option of going anywhere in the United States and have it fabricated at a local structural steel shop versus having everything fabricated by Blue Scope Steel, which now can't. I mean, they like big companies like Amazon and big companies like Home Depot, they bought up the market. Joist system. So I mean, if you want joist, it's a year. If you way you get around this is make your own, which is what we did. So we're okay now on that. We do have to hunt around a little bit for the structural steel, but not for the joist. The joist system we got pinned down, so we're good on that. But you can get it. You just got to hunt around to find that's why before we even start to design, our engineering department will search out the shapes that they want and see what the availability is. And if we have to adjust the size, maybe we have to go up a size. Maybe we have to go down a size and reinforce it. So, it is, you got to pull out all the stops. And, I've been in construction this long. This is, a no-brainer. I mean, what we have to do, you have to do. So it's just the way the world is working right now.
The renderings look beautiful, but how close to those renderings will the actual structure be?
That's an exact match.
Yeah.
We could show you, like I say, we could go show you building after building after building. It looks just exactly like that. The only difference is the roof in the back area is clear, and it's almost a flat roof. So you don't even notice it really. I mean, the walls on the outside, we run the walls up, insulated panel up to 7'6" as a security wall. And then from there, we roll up with the, transparent panel. But see, that's the whole thing. Even this affects the cannabis market, because here's the model that we can use with this greenhouse, which a lot of people haven't thought about. And I've approached Amazon with this business model. But you can take this greenhouse, see, because it's not a greenhouse. It's a commercial building functioning as a greenhouse. So I can take this to any municipality in any state, and I can build that right next to your Vons, Ralph's, Albertsons, Starbucks. I can go to any retail center and build that building, and you can cultivate, and you can process, and you can retail all in one location. Because see, Amazon's getting into it's called Amazon Fresh. They have about 8 stores built. And of course, there's this food, it's not cannabis, but on the cannabis side, you can do exactly the same thing. And guess what that does? You eliminate buying the cannabis, you're producing the cannabis, you're processing it, you eliminate the brokers, you eliminate the transportation, you eliminate all the labor of transportation, getting on the trucks, getting it off of trucks, and stocking it. So it's a business model that works. And, the food group especially, I mean, there's some of them starting to do it somewhat, but if you're going to, you want to cut all this out, you're going to need to cultivate on site. And with this building, you can, because it is accepted by all building departments, because it's a commercial building. It's not a greenhouse. They're not going to allow you to do that with a greenhouse, but, because they're energy efficient. In fact, our meeting up there in California Energy Commission at Title 24, which is Title 24 is all your regulations that pertain to the building energy usage, and that brings in the insulation value of the walls and insulation value of the roof and the rooms, and how much power you're actually going to use for the facility. And they just call them gross violators. Anybody, and in what he told me up there is that California is going to discontinue gas hookups. So now you're not going to be able to use gas anymore on new construction. And of course, California does have these brand new regulations now. They just posted, they're effective January 1st of this year. They give them a year grace. So you're going to get until January 1st of next year, 2023. But HPSs are completely outlawed. You can't use them at all. And you have to have a certain R value now for the walls, and you have to have a certain R value now for the roof. That's why I'm saying we exceed that by 4 times of what they're asking for, because we're using this dual membrane system. So it's all about energy. It's a clean room operation, and it's also energy conservation is the entire building system is with that in mind.
I mean, I've heard a lot about companies striving towards vertical integration. Very little of it all in one building.
Yeah, that's why you don't have to be that big. You're gonna do your research and find out how much you're gonna, what the anticipated sales of that area, and you build it accordingly. Whether it's cannabis or whether it's fresh greens. So, again, each room is broken up. You break this thing up, people wind up, personally, it's a mistake as far as I'm concerned, in my opinion, of building several greenhouses, littler greenhouses. With this building, you can build just like Amazon does. You can build 5 million square feet of greenhouse if you want. See, and then you just break up all the rooms into, what you would consider individual greenhouses. So there's no limitation on this building system, and there's no height limitation. So it's the same system we use aircraft hangars. So, those go 120 feet tall. You want this building 120 feet tall? No problem. Do you want it to resist 200-mile-an-hour winds? No problem. Again, the system, the transparent system that we're using is Class A fire rated, won't burn. It is snow loaded. It is, hurricane rated Dade County, as I mentioned earlier, and it's impact rated at 100 mile an hour with a 1-inch hailstone. And it's a 2-to-1 safety factor. So before this would ever go through that membrane system, the outer membrane, it would have to be doing 200 plus to get through. And you got to remember, this is a dual membrane system. So even if it damaged the outer membrane, the interior wall and interior ceiling is still protecting your crop. If you get 60 mile an hour winds on traditional glass greenhouse, it's going to be laying in your lap. They will go, they can't take that wind load. So, and not only that, but, glass produces a lot of heat. It's made from sand. So it's like a rock. It's going to radiate a ton of heat. So, that pretty much kind of covers that piece of it.
What is the CRAM generator? Well,
the CRAM is the key piece of this whole thing. Mm-hmm. So when I went to the California Energy Commission, they mentioned that they're going to discontinue gas hookups. Okay, because initially I had a lot of the system designed in gas. Coming from the grain farm operation in Iowa, in fact, all of the grain drying is done with gas, and they have some very efficient units. So I took that technology and was employing it into this greenhouse. Well, I went up there and he said that, and I go, well, you know what? California is a big market. I'm going to need to go back to the drawing board here and eliminate gas and make this whole system electric. So what I did is I went back and I used my background and knowledge, because in the farming community, we use generators a lot. And we've had those apart a million times, as long as the same thing as electric motors are used everywhere in the farming community. So I took the knowledge that I already had and advanced that, and then I studied jet technology. And what I did is reconfigured the electric motor and generator into the same configuration as a jet engine. I am still doesn't use fossil fuel. What this system does is it's unitized on the inside. And this is what the patent application is all about. We took a traditional CRAM stands for counter rotating alternator motor. So the generator and motor operate in counter rotation like this. And we can individualize the plates so that the plates on the inside are rotating at 6,000 RPM, so that the face value of that is 12,000 RPM because it's counter rotating. And what that also does is it counter rotates the torque, because one's creating a torque to turn something, the other one has a lot of resistance of turning it to create your power. So we create the counter rotating to offset the torque so the unit doesn't want to flip over from the torque. It's just like a combustion engine that, the torque of the engine when you take off wants to lift the left wheel off the ground like they do in a semi. It creates that kind of torque. So you have to counter react that. But what the CRAM generator does is it runs 365 24/7. What that will do is it doubles the output of what it consumes. So if your facility, and of course it is designed according to how much power is at the site. So when I say that, some sites don't have nearly as much power as other sites do. So you have to boost that power, not boost it, but you have to duplicate it, to have enough power to power your facility. So what happens with that is that if this unit and your power to the site is enough to power this unit, so that the motor side is using 4,000 kilowatts, the generator side will put out 8,000 kilowatts. So you're doubling the power system. You're doubling the power. So now, let's just say your facility uses 7,000 kilowatts. So you're burning 4 with this unit, and you're getting 8 kilowatts out the back. That means you're running your facility on this CRAM generator, and the extra thousands going back into the grid again. So you're only using so much out of the grid, but you're putting back into the grid and you're powering your whole facility. Plus, this operates on DC. It puts out both DC 483 phase and 240 phase. And the reason we use DC is because it's so much more efficient, and that's what we use to power the unitized motor components is DC, because it's like in Tesla's cars. The DC, this is why you see Tesla's beating 1,000 or 800 horsepower Hellcats, because DC is immediate, where with a combustion engine, it takes them to get to 6,000 RPM to develop that kind of power. So with DC, you have instant torque, and the torque curve is way higher than AC. So we use DC. Not only that, but this particular system will also, because it's producing DC, we can run the HVAC systems on DC. So we can get the system on net zero. You're using no power. Mm-hmm. And I mean, you're using power, but you're using the power that's there to create your own and then put back in the system again what you're not using. But the DC can also go to charge up your Tesla battery field in an event of a power failure. Now, the CRAM also has an optional fossil fuel powered engine. And this, of course, this engine is not any engine that exists in the world today. It is an engine that will run on any fuel. It doesn't matter if it's gas, kerosene, biodiesel, diesel, LP, it will run. It has an injection system for both air and fuel. It regulates that, so you regulate the compression of the engine. But the crankshaft is a armature, and the pistons are magnetic. So you use a polarity system that, when you're using magnetics, they'll pull to each other and then they push each other away. So you use a reverse polarity system where the pistons go up and down. It sucks the piston to the top, and then it pushes the piston down on reverse polarity. So this is a completely brand new engine. Again, this is new technology, but we're using existing combustion engine technology, but it's being completely refigured. It has no valves in it. So all that happens, a porting system. So all that happens is you put so much pressure in there, like diesel fuel, you need 18.5 to 1 compression to ignite the fuel. Well, with LP, you don't need anything like that. You need to be down in around 4.5 to 1, 5 to 1. So again, we have a backup engine that can go on there, or it can be a standard diesel engine if you want to in a power failure, but you can also charge up a Tesla battery field, and you can run off the Tesla battery field for 5 days if you have a power failure.
Okay. Have you prototyped the CRAM generator yet? Or is that something that with the new building, you're going to have to create the generator as well?
Right. It's going to go into the new building. We're under NDA with the military, and they want the same thing. But, here we are. It's going to cost $1 million to build this CRAM generator in that configuration. Yeah. Have I built a small one that we know works? Yeah, we know that works. We just got to put it into a big form. So I've spent, $600,000. I've self-funded everything.
Oh my goodness.
So, I'm getting to the point where either somebody buys this system and, we're going to guarantee the system. I mean, the engineers are going to stamp this. It's backed by engineers. But at some point in time, if, we have to go the other route, we'll take a secondary source, an investment firm or a group that would like to invest in this technology, and take them on as a partner to build the first one. So look, we're using traditional electric motor and power generating principles. It's just a complete reconfiguration of the interiors of the motor system. And if one of these disc armatures fail, you have 10 more that keep running. In a regular electric motor, the one barrel armature in there, if it shorts, it's done. It shuts off. And that's the reason for unitizing it on the inside and making it 10 armatures instead of 1. So if one fails, you still keep going.
I found it really interesting, and I know that we're running short on time here, but I found it really interesting talking about how the building will mimic other climates. So do you see that as a selling point for maybe MSOs that have, that want to run the exact same operation just in different markets? Or do you see that as more of a boutique thing where you can grow, something from a tropical climate in Colorado?
Well, it's kind of all of those.
Yeah.
Okay. When you can replicate what goes on, and the whole thing is the earth has some vibration, so that that's employed into our growing systems. We won't get into our growing systems. It's just, in a nutshell, our growing systems are enclosed. There's no soil or no water exposed. They're enclosed. Each plant has a individual CO2. And if we use a soil system and it's an injection system, it's not a drip. Everything is injected right at the roots. But that just, in a quick nutshell, plus it's enclosed. So we wind up with a climate. They're called climate tech tables, meaning that we create its own climate. It's enclosed itself with clear panels. So we create whatever. We can put the blackout system right on the table. If you want to black out 20 tables, you can do 20 tables and not the whole building. So, that's how our system operates on that. But yeah, we can recreate any atmospheric, you got, when you're talking about growing, you're talking about vibration, that the earth actually has. You're talking about soil temperatures, and you're talking about humidity, obviously. And of course, there is barometric pressure. So in this greenhouse, we can regulate your pressure, because it's sealed. It's just like a dang balloon. You regulate how much pressure you want in there. So if you want to put a pretty high barometric pressure, which a lot of people believe in, you simply, cannot do that. I'm sorry, in a regular greenhouse, because they're not sealed. And a lot of these guys, the roofs open up on these things, and it's like, why are you doing that? You're inviting every airborne contagion into your greenhouse, and you're allowing every pest to come into your greenhouse. I just don't understand it at all. If you're growing poinsettias, that's one thing, but you're growing cannabis, especially medical. You don't want anything in there, period. You want pure air. That's the reason for our air sterilizers. You don't want dirty air even in there, which you can obviously get airborne pathogens come in. That's why we have that, airlock actually to purge all that before you actually bring it in. So yeah, it's to answer that question, it's really all the above. And you can replicate that, from there to here or vice versa. So like they're growing hops or they're growing grapes, they say, this wine comes from this place in Germany, someplace, and it's the only place you can grow them. Well, you can replicate that. See, you just set your sensors up there and take a year cycle and then input that into the control system. And that's exactly what you're going to get. There may be some modifications. You may have an unusual year or something. The software system may have to be modified a little bit. But at the end of the day, you're basically just taking that information, plugging it into your control system, and it does it all. It's just a software system.
Do you ever get back to that family farm in Iowa?
Oh yeah, I go back every year. It's like traveling back in time. It really is. It's a whole different life there. It's a whole different, way of looking at life there. The rural people are literally down to earth, and that's how they live. I mean, a lot of things. Of course, everybody has contracts these days, but it's a trusting community, and if there's someone there that's not trustworthy, they are known. But outside of that, I very much go on. We have river bottom land, so we go back and we do fishing and hunting back there. It's always a nice change from the city streets, so I really enjoy that.
Well, Terry, thank you very much for taking the time to share this new technology with me. I really do appreciate it.
You're welcome. It's just a way to try to get it to the right people. Again, you can reach out to a lot of people, but you're maybe not always getting to the right people. So a platform like yours is a great place for people to sit down when they have some time and actually listen to it and pick up some points that would certainly ring true to them, especially the problems they have in greenhouses with condensation. It's a big killer.
Well, thanks again, Terry. I really do appreciate your time, and I do see promising things for AGT Technologies going forward. Before we get out of here, please make sure to like, share, and subscribe to the podcast. You could also do us a big favor by leaving us a positive review on whatever platform you use. Finally, to reach the podcast or suggest a potential interview subject? What am I doing there? Anyway, if you think somebody that would be good on the podcast, send me their info at david@cannabisequipmentnews.com. All right. Terry, again, thank you. I'm David Mancy. This is the Cannabis Equipment News Podcast, and we'll see you next week.
Thank you for listening to the Cannabis Equipment News Podcast.